In the vast, cold, and seemingly silent expanse of space, a lone traveler continues its journey into the unknown. It moves steadily through a darkness so ancient that even light feels fragile within it. This traveler is Voyager 1, the most distant human-made object ever created, a tiny metallic fragment of Earth drifting through interstellar space, carrying with it the fading echoes of the world that launched it. More than 24 billion kilometers from Earth, Voyager 1 exists in a realm where the Sun is no longer a dominant presence. It has diminished into a faint point of light, indistinguishable from countless other stars scattered across the sky. From this unimaginable distance, the entire solar system has collapsed into a single unresolved memory. The planets that once filled telescopes and textbooks are now nothing more than lost coordinates in the past. And yet, Voyager still speaks. Its signals are incredibly faint. They travel at the speed of light and take nearly a full day to reach Earth. By the time they arrive, they are barely distinguishable from background noise, weaker than the flicker of a distant star. Engineers must carefully filter and amplify these fragile whispers until meaning emerges. Inside those transmissions lies something extraordinary. They are not just streams of data. They are proof that something built by human hands continues to exist and function far beyond the boundary of our solar system. When Voyager 1 launched in 1977, the mission was never meant to last long. 5 years, that was the expectation. Visit Jupiter, study Saturn, transmit data, and then slowly fall silent as its power systems declined. The spacecraft was built with technology from an era before the internet, before smartphones, before the digital world connected humanity. Its memory was tiny, its computing power modest. By today's standards, it would seem fragile and outdated. But space has a way of rewriting expectations. Voyager's journey began during a rare planetary alignment that occurs only once every 176 years. This alignment allowed scientists to design a path that used the gravity of giant planets as natural accelerators. By carefully navigating past Jupiter and Saturn, the spacecraft gained tremendous speed without burning large amounts of fuel. It was an elegant solution, a cosmic slingshot that turned planetary motion into propulsion. When Voyager reached Jupiter, it revealed a world of immense turbulence. Storms larger than Earth raged across the planet's atmosphere. Lightning illuminated alien skies, and vast auroras danced along magnetic fields stretching millions of kilometers into space. Jupiter was not a quiet giant. It was alive with motion and energy. Then came one of the most groundbreaking discoveries in planetary science. On Io, one of Jupiter's moons, Voyager detected active volcanoes. For the first time in human history, geological activity was observed beyond Earth. Massive plumes of sulfur and ash erupted hundreds of kilometers into space, revealing a moon alive with internal energy. This discovery shattered the belief that distant moons were cold and inactive worlds. At Saturn, Voyager uncovered another layer of complexity. The planet's rings, once thought to be smooth and simple, were revealed as intricate systems made of countless particles of ice and rock. These particles, ranging from microscopic grains to massive chunks, moved in delicate balance shaped by gravity and resonance. The rings were not static structures. They were dynamic and constantly evolving, filled with waves, gaps, and patterns that hinted at hidden forces shaping them. After Saturn, the mission could have ended. The spacecraft had fulfilled its purpose. It could have been allowed to drift silently into the vastness of space. But it did not stop. Carried by momentum and guided only by the laws of physics, Voyager continued outward toward the invisible boundary of the Sun's influence, a region known as the heliosphere. This immense bubble, created by the solar wind, surrounds the entire solar system and separates it from the interstellar medium beyond. For decades, scientists debated what crossing this boundary would be like. Would it be sudden? Would there be a clear dividing line? On August 25, 2012, Voyager 1 provided the answer. It crossed into interstellar space quietly. There was no visible boundary, no dramatic event. Instead, its instruments recorded subtle but unmistakable changes. High-energy cosmic rays increased sharply. Solar particles decreased. Plasma density shifted. Voyager had entered a new environment no human-made object had ever experienced before. Beyond this boundary lies interstellar space, a medium so sparse that atoms are separated by vast distances. And yet it is not empty. Voyager detected low-frequency plasma waves, faint vibrations traveling through this thin medium. Scientists believe these signals may be echoes of ancient supernova explosions, shock waves from dying stars still moving through the galaxy millions of years later. Voyager is listening to events that occurred long before humanity existed. Communicating across such distances remains one of humanity's greatest technical achievements. A signal from Earth takes more than 22 hours to reach the spacecraft. The reply takes just as long to return. A simple exchange spans nearly 2 days. And yet, the connection remains. Attached to Voyager is one of humanity's most symbolic creations, the Golden Record.